And so therefore, when we understand in a scientific sense, the understanding of something that goes on forever, something that goes on infinitely, it's still within the context of a world of time, of which that dimension is present. When we speak of the infinite in the divine in terms of God, we see an existence that is not conditioned by time, that is not conditioned by any of the material dimensions of the world. And so therefore there is a difference in terms of, if to borrow a little bit of Wittgenstein, that it's not necessarily the term you use, but what's the definition underneath the term that's being used. When we understand the idea of an infinite God, it's not that there is a divine clock that goes on in heaven that can measure in a never-ending heaven. It's the idea that when you are in that realm of God, there is no time. Time does not exist.
Yeah, well, that's very nice. That is actually compatible with the way science has been going. More and more scientists are increasingly leaning toward time just being something that we humans create to make sense of things. Unlike Newton, who thought it was an actual dimension, more and more people are like Immanuel Kant, who think that it's like our numbering system. It's not something that's real, like a cucumber. It's nothing you can examine, and therefore, you certainly couldn't travel through it, and it doesn't have independent existence by itself. So what you're saying is actually more and more in keeping with the way science is going, that there really is no time in reality, and the underlying reality anyway.
Yeah, and that's and thank you for that correction. I appreciate that, because one of the things in theology we're always careful to distinguish is to emphasize that one of the things that I oftentimes see people who are trying to critique faith from a scientific standpoint, a mistake that I see them to make, is that it eventually tries to make God one being within creation, and to constantly go back to that understanding that God is not a being. And it's something that is very hard for the human mind to grasp, of thinking of something, an entity that's not a being itself. And so I appreciate your correction, in terms of the understanding of time. So thank you for that.
No, that's in keeping with the line of passive understanding, isn't it? I think this, what we're talking about really does passive our human symbolic language, where we have words for things. I mean, actual water is not the word water. So we try to understand things with our symbolic representative language, but it's becoming clearer and clearer that there's an underlying reality that's beyond what we can even think.
I think it's interesting you say that. A former classmate of mine from seminary, Father John Carchi, was just named rector of Mundelein Seminary, and he was an astrophysicist. He received his PhD from the University of Chicago. And for me at that time, being that I was just an infant at that point of trying to understand intellectually this relationship between faith and science, I had a conversation with him, being that here's an interesting guy. He's an astrophysicist, but also studying to be a priest. How do those two work for him? And precisely to your point, when I was all curious about, how does he see this all fit together? One of the things he shared with me in reflection was, he's like, James, one thing you have to remember is that it's not faith in the biblical sense, but there is an underlying faith that an astrophysicist has, that the numbers, the symbols, the expressions that are being used actually work the way you think that they're working. And speaking precisely to what you talk about is that we have these realities that we give names to, such as water. But at the same time, there's also that exploration of human reason and refinement of human reason that has contributed to that language and will change the language in the future, and will refine it even further and give us a better understanding of the natural world. And in that process, we'll also be able to get a better understanding of the divine and of God, in terms of, as we better know how the universe works and how the world works, it gives us a deeper sense of our understanding of the source of that universe and how that source relates with us.
Fascinating. We've been speaking with Father James of the Vatican Observatory. We're doing this here at Slooh because this is the day of the lunar eclipse that's uniting many, many people in the world, looking at an event that the moon and the earth are both intimately involved in. And so, of course, here we are all together very much concerned with our planet Earth and the issues that extend beyond it. So this was a fascinating discussion. We're really in your debt for you joining us here today. Thank you, and perhaps we'll speak to you again in the future. We appreciate you coming on.
Thanks, Bob, and thank you for everything you do. I'm a Slooh member, and I remember just watching your little clips that you have when I would schedule time on one of the telescopes in the Canary Islands or in Chile. Just listening to your 5 or 10 minute explanations of these objects really helped me understand the universe and nebulas and stars. And so thank you for everything that you do. And on behalf of the Vatican Observatory and the Vatican Observatory Foundation, I just thank you for inviting me on. I deeply appreciate being a guest on your show today.
Hi, I'm Paul Cox, I'm Slooh's Community Manager, and I'm here to guide you through the huge variety of activities you can do with Slooh, whether that's taking your first image or maybe learning some advanced image processing techniques. But in this activity, we're going to guide you through all of the steps necessary to replicate the discovery of Pluto. Now you'll find all of those individual steps lower down on the page, but first let's remind ourselves of how the discovery story unfolded. Well, after only 3 years building his first telescope in 1926, at the age of 20, a farm boy named Clyde Tombaugh sent his drawings of Jupiter and Mars to the Lowell Observatory in Flagstaff, Arizona. Now, expecting only to receive a helpful critique of his work, he was surprised to be offered a job at the observatory. In our dreams, I hear you say. Now, he worked there from 1929 to 1945, but it's the discovery he made during his first year there that has written his name into the history books. He'd been charged by the observatory director there to continue their search for the mysterious planet X, and it was thought to be responsible for some anomalies that had been measured in the orbits of Uranus and Neptune. But it remained undiscovered. This mysterious planet X remained undiscovered for decades after that was first postulated. Now, the young astronomer, he spent his nights guiding Lowell's 13-inch telescope whilst exposing these photographic glass plates for hours at a time. Now, each morning he would process the plates before comparing each plate of the same area of the sky several nights before. He used a piece of equipment called the blink comparator, comparing two of the huge glass plates in detail through a magnifying lens and blinking each image in an attempt to identify any moving objects, in other words, planet X. He did actually discover quite a few asteroids in this process as well. But on the 18th of February 1930, nearly a year after he started his systematic search, he discovered a moving object between the photographic plates he'd taken on the 23rd and 29th of January 1930. He went to the office of the observatory director and exclaimed, "Dr. Slipher, I have found your planet X." What a great day at the office that must have been. And the rest, as they say, is history. Clyde Tombaugh had discovered the 9th planet of our solar system. News of the discovery spread around the globe, aptly named after the ruler of the cold and dark underworld by an 11-year-old English schoolgirl. Pluto's first 2 letters also honoured the observatory's long since dead founder, Percival Lowell. And now, 85 years after its discovery, 18 years after the death of its discoverer, Clyde Tombaugh, and a mere 9 years after Pluto's demotion from a planet to dwarf planet, we're finally destined to explore this tiny world, only a sixth of the mass of Earth's moon, together with its own retinue of tiny moons in unprecedented detail. And it's NASA's Pluto Kuiper Belt mission, New Horizons. It was launched in 2006. It used this gravity-assist slingshot maneuver around the gas giant in 2007 and is due to reach Pluto in July 2015 before speeding on to study other objects in the Kuiper Belt. What better way, though, to mark this incredible story of Pluto's discovery and future exploration than to replicate the discovery methods used by Clyde Tombaugh at the Lowell Observatory, but by using Slooh's modern scientific CCD cameras and telescopes. And in this activity, we're going to guide you through all the stages necessary, from scheduling your Pluto missions, aligning your images, before blink comparing them just as Tombaugh did, in order to spot the tiny white dot of this tiny world moving against the rich backdrop of the Milky Way's star fields. Just follow the steps on the Discovering Pluto activity page and watch the instructional videos as well. Shout if you need any help, and please share your results with other members in the clubhouse. That's all for now. Have fun. I hope you enjoy this activity. Goodbye for now.
Hello, and thank you for joining us here on Slooh. My name is Trisha Ennis. I'm the resident mythology expert here. Now, in another installment of the series, I told you all about the ancient tale of Orion, the mythical hunter. But with a constellation so visible and so popular, it's unsurprising that the shape, its stars, and other objects within it would continue to pop up in modern fiction. Diving deep into the constellation, we find the gorgeous Orion Nebula, an emission nebula that stands as one of the closest star-forming regions to Earth. This bright, beautiful stellar cloud has popped up in a few popular films, or at least their franchises. The Orion Nebula was a major player in director Darren Aronofsky's 2006 film The Fountain, where it serves as the setting for the futuristic portion of the film. It is the place to which Hugh Jackman's character travels in order to revive the Tree of Life, which houses the soul of his deceased wife. If that sounds strange or confusing, you should see the rest of the film. The nebula also appears in a franchise near and dear to the hearts of many sci-fi fans, Alien. While it doesn't appear in any of the films, a video game expansion of the Alien universe, and of the Alien vs. Predator movie, charts the origins of the terrifying xenomorphs to a planet somewhere near the Orion Nebula. Pulling out a little farther, we can look at some of the individual stars of Orion, namely its two most famous, Betelgeuse and Rigel. Rigel, or the fictional Rigel star system anyway, appears in a number of TV shows, books, and movies. These include the widely despised Fantastic Four: Rise of the Silver Surfer, Buck Rogers in the 25th Century, several episodes of Star Trek from the original series all the way through Enterprise, The Simpsons, and, of course, The Hitchhiker's Guide to the Galaxy. Hitchhiker's Guide also plays around with the other well-known star, Betelgeuse. A couple of the main characters from the Hitchhiker's Guide series, Fort Prefect and his semi-half-brother Galactic President Zaphod Beeblebrox, both hail from a small planet somewhere in the vicinity of the Red Star. In the original Planet of the Apes, I'm talking about the novel rather than the oft-quoted Charlton Heston film, the manned ship is attempting to head in the direction of Betelgeuse, traveling at the speed of light. Of course, when they eventually reach their destination, they're a little off course. Perhaps my favorite appearance by this star and its fictional system is its place in H.P. Lovecraft's Cthulhu mythos, where it serves as the home to a group of the more benign elder gods. But what if we come all the way back to Earth, and back to a familiar and usually brilliant meteor shower, the Orionids, which appear in the sky each October. While it isn't referred to by its common name, the Orionids also appear as a major plot point in at least one television show, the Sci-Fi Channel's supernatural drama Haven. In the show, which is based on a short novel by Stephen King, A young woman appears in a town once every 27 years. She always looks the same and always has the same uncanny ability to assist the denizens of this sleepy New England town with their myriad of troubles. One other thing that never changes, she always disappears at the same time on the night of the Hunter meteor storm. While they never refer to it as the Orionids, it is the only meteor shower which shares its name with a mythological hunter. Let's just all be happy that the real-life meteor shower doesn't have the same results as the one on the show. So I'm curious, do you have a favorite fictional appearance of Orion? If you do, we'd love to hear about it, so feel free to share your thoughts with us on social media or in the chat room right next to this video.
Many of us who work for Celestion, we're amateur astronomers ourselves. We love going to these type of events. If you look around and you see the people who come to these shows, anywhere from grandparents to teenagers to little kids, it just inspires people to look up and wonder what's up in the night sky. Same way when we were like little kids, what inspired us to look up. And it's like for us to give something back and to inspire them so that they will grow up, and who knows, someday they may become the next engineers and mathematicians, or even become a telescope engineer. You never know. Sky's the limit, right?
Prior to working here, I didn't have any astronomy background or experience, but it's something that I've been able to not only learn quickly, but just come to love very quickly. And it's also been really helpful because we do have products that range from entry level to advanced. And for me, it's really nice because I'm able to have those conversations with people who are just starting or people who have never looked through a telescope, and I can actually relate to them because it's not so long ago that I was in their shoes. So it's been a learning experience, but it's been awesome.
We actually have people consistently will come around to the front of the telescope the first time they see Saturn, and they actually think they're going to see a sticker on the front of the telescope because they can't believe that it's a real thing. Like, no, that's a part of nature, that's a part of the cosmos.
Because it brings so many people together. People of different backgrounds, people of different ages and different levels with the astronomy. That's something we want. We want to be able to bring people together and show them the stars, and understanding that you are a part of this bigger thing. And even though you are a small piece of it, you can play a major role in it.
Getting out here with people, whether they know about astronomy or not, whether they've looked through a telescope before or not, we really want to get just as many people behind the eyepiece as possible. This type of science and this type of culture of science really changes the world, and we want to be a part of that. We show people Saturn for the first time, and it blows their mind, and it always reminds us why we got in the hobby in the first place. So that's very important for us.
Today we're seeing that annular solar eclipse where we have that ring around the sun where the moon isn't quite big enough in our view to cover the whole sun in our view. And then we have the total solar eclipses where it does reach that mark, where it does get big enough to cover the entirety of the sun. You see those majestic images of just the flowing corona surrounding it and things like that. And then we have the partial solar eclipse where you're getting bite-sized chunks. You're eating a little bit of that cookie, but there's still some of the cookie remains. The moon has not passed over all of the surface of the sun in our view. And then there are the hybrid eclipses, which are a combination of both annular and total. The subtle variations of the curvature of the Earth, of the geometry of Earth, can mean the difference between the moon covering the entirety of the sun versus the moon covering almost all of it and having that ring around it. And so there's this combination factor that starts to come into play. And this is a really rare event because you only get hybrid eclipses about 5% of the time when eclipses come our way. And really, eclipses aren't that common in general.
So we just happen to be living at the ideal moment where we can see total solar eclipses.
Exactly. And this really ties in with some metaphysics or philosophy, because people are often asking, is there an intelligence? Is there God behind everything? Is there evidence for it one way or the other? But many of the things people see magic in are honestly speaking, they're coincidences. However, in this one case, the fact that we have only two disks in our sky, the sun and the moon, and they both appear exactly the same size, which we've just seen, so that one can cover up the other to produce these marvelous eclipses, especially the total kind coming up next year, where we see the nuclear flames coming out of the edges and the corona. What are the chances of that? Well, of the 144 moons in the solar system, no other is just the right size where from the surface of that planet would they see one of their moons and the sun appearing the same size in the sky. And as you were just bringing up, that wasn't the case with our moon, because our moon was significantly farther, closer in, only 1 billion years ago, it was not even close to matching the sun in size. It was too close to us. And as it spirals away at 1.5 inches a year, it's getting smaller and smaller.
Why bother trying to bring astronomy to the general public like that? Why is it so important?
I mean, I can give my own personal reasons. I've always just loved knowing what's out there. We're trying to reach as many people as possible and just show them, look what's happening right above you right now. And they're always amazed, and that's wonderful. If I could add to that, I think that we spend so much time just focused on what's happening on this small scale. We worry about what's happening in our lives. We worry about politics. We worry about all these things that are actually, on a universal scale, are quite petty. They're quite small. Yeah. And I mean, they do affect us, but it's good to have that perspective to see that there's so much more going on.
With the annularity, that motion that's going on there, it's real time in a very significant way. Like you're seeing the sort of the moon go in and sort of the sun starts to hug it, then you get the annulus, and then the moon goes off the other way and the hug parts. And then once again, you have these two objects as opposed to this singular alignment.
Ding! And you could see it, couldn't you, Eric? You could see that there wasn't one point there where there was a total, line of the sun. You could see that there were bumps and ridges. It didn't just kind of pop out. It popped out through those ridges, didn't it?
It wasn't all at once, and now all of a sudden there's this ring. There's the sun. There's the moon. And one's on top of the other in our view. It's the annulus,
and it's going to last maybe a minute and a half from reunion. So here we are, Eric. You've been describing this in your wonderful segments earlier. An annular eclipse. That is the annular eclipse. It's the ring of fire that everybody talks about. Now, that if you were standing there now, it would still look incredibly bright. You should not look at that, an annular eclipse with naked eye. You still have to use eclipse glasses. It's not like a total solar eclipse. And Eric, what's the biggest difference, what you would see visually between a total solar eclipse and what we're seeing here?
I mean, one, I think, is that I just remember sort of the last total solar eclipse we had over there. It was just the transition from sun to corona, this vast sort of flowing corona that happens during the total solar eclipse. And here, the main draw is sort of the very edge of the sun itself, that ring that surrounds it, and so not the corona flowing beyond. And so we get different highlights with different eclipses, different experiences. This ring is not something you can see with a total solar eclipse, this very edge. And so it's a bit magical in its own way. How many annular solar eclipses have you seen, Paul?
Well, I think this is the first one, actually. Yeah. I want to see, Eric, whether or not we can see that same phenomena of you know, on this third contact, this is the end of the annular phase. I want to see if we can see those ridges, the hills and valleys on the edge of the moon. You can see
And we
them,
see it
can't
moving
you?
to the other side.
Just there. Yes, it's just not a perfect circle coming out of another perfect circle, is it? It's very much, you know, high points and low points. There, you can see it. That's so dramatic, isn't it?
That's
And
amazing.
that's it.
I hope to see a replay of that eventually,
I
slow
do.
motion.
I was at the 1992 total eclipse in Mexico, and that was fantastic. That we had, I think, more than 4 minutes of totality, and that was amazing because everything went dark and the animals started behaving differently, and everybody was really amazed at how much change took place. Today there was less dramatic change. It did get dim. It was really spectacular to see so much change, subtle change, but change nonetheless.
So what was your reaction then? You know, because frankly, it just takes me to tears.
It's like a roller coaster of really intense emotion. And, you know, the first part of it was quite interesting. And you're watching as the moon moves across the sun. And it's kind of like, yeah, that's cool. That's interesting. And I thought that's all it was going to be. I didn't really expect that, you know, probably the 5 minutes or so before when everything goes so dramatically different. I wasn't expecting that. And I wasn't expecting how physically I would respond to it. So that sense of pure excitement and, you know, it was like my heartbeat was in tune with the environment around me. And you couldn't help but just be in awe of the universe at that point. And the light was rapidly diminishing, and I didn't have enough eyes to take it all in. It was just so many rapid changes and moments. And then the overwhelming moment when the moon completely moves in front of the sun. I mean, it's just spellbinding, and it's so out of what you normally experience. I think it's important not to just look at the eclipse that's happening, or not just to spend all your time looking through your solar filters. You must look around you and see and feel. And so with those directional changes in light and the color seem to be removing from the environment, it's like you're in an old-fashioned film or something. And the final moments happen, and it's so quick and dramatic, and it's overwhelming. So the roller coaster of emotion that you have really captures you. And then you have that intensity of you know, that feeling of connection.
We had this eclipse and this journey to get to it, and that was our treasure at the end of this really long journey. And as we're seeing all these different people come together, I know this is a little bit of a trite statement, but I think a lot of it is all about the friends you make along the way, about this sort of community that forms around this one sort of focal point that's amazing in astronomical ways, but also amazing in emotional ways, and how it moves us in all the different ways that it changes us. And so I guess I gotta say that my favorite part of this whole thing is the fact that I think I got to, in some ways, meet and interact with people I never probably would have otherwise, to be a part of this community for this moment, and maybe for longer if people decide to stick around. But just, you know, having that sort of worldwide hug that goes on, as cheesy as that may sound.
Have you ever looked up into space, staring out at those countless stars in the night sky, and wondered whether or not we're alone in the universe? As of the 1st of June, we've discovered 3,422 exoplanets. There's the star right in the middle of that. What is an exoplanet, basically?
It's about a planet that is around a star other than our sun, something that is strong enough to have its own gravity, it's going to be sort of a sphere-like object, but it's also not going to be too big that it can get to the area of stars, start fusing, start having light of its own.
So it's really helping us with our own place identifying our own place in the universe, you know, and this is what so many of us get so excited about when we think about astronomy. And it's, you know, it's almost spiritual when you start thinking about the numbers, the vast distances involved, and you know what we're coming up with now. You know, I went through those statistics. You know, we can virtually point to any star now, and there's a pretty good chance that there's a planet of one kind or another, you know, orbiting it. There we can see it, that star in the center. It's, what is it, 132 light years away from us. But, you know, we're making new exoplanet discoveries at an ever increasing rate, as I told you at the beginning. And most of those discoveries are made by seasoned astronomers from a couple of large-scale programs, the Kepler Space Telescope for one. But 4 potential new exoplanets have been discovered by an undergraduate student, Michelle Kunamoto.
Part of it is just want to answer the question, are we alone? And I think planet hunters are actively working towards realizing that, you know, the search for life, finding habitable worlds or potentially habitable worlds. My supervisor's old PhD student, Jason Rowe, actually was on the original Kepler team. So he wrote a lot of the codes that NASA used. So my supervisor actually just called him up and said, hey, I've got this student. She's looking for a project exoplanet related. Do you have any ideas? And he suggested that I look through Kepler data just for anything that, any planets that they might have missed or weren't looking for.
Well, right now I want to welcome Roger Phillips, who writes a webcomic.
I always wanted to be a cartoonist, and I love the topics of the aliens, and then I combined the two, and then here we are. I think that we look at them as they are the next step of human evolution. So they are free of all our, you know, tendencies to be violent or greedy or jealous. And they are, you know, they have perfect intelligence. They are very logical in their approach to everything. And I take off on that notion and then put them in very silly circumstances. So it seems absurd that these perfect beings would, you know, have trouble with opening a beer can or, you know, buying a home or something very simple like that. So that little paradox I think seems to work with the strip.
So here you have saltwater oceans. You have comets that have carried all the amino acids onto Europa, more comets than have even hit Earth over the years. And you'd have to say that if there is not life in those protected saltwater, warm, amino acid drenched oceans, then we have to really rethink the likelihood of life elsewhere. And it really could be then that Earth is the site of a miracle.
Will mankind wipe out by a huge space rock, just like the dinosaurs? How much do we understand about asteroids? What exactly is the risk? In the words of Dr. Brian May, one of my favorite musicians and co-founder of Asteroid Day, it's one day each year to learn about asteroids, the origins of our universe, and to support the resources necessary to see, track, and deflect dangerous asteroids from Earth's orbital path.
It's a pleasure to be here on Asteroid Day, which is June 30th, which is as you know, the anniversary of the Tunguska explosion in 1908, where a 45-meter asteroid hit the Earth's atmosphere, releasing enough energy to destroy roughly 800 square miles. And that is what the B612 Foundation was founded to prevent. What we have demonstrated is that the combination of an infrared space telescope like Sentinel in combination with the LSST, which, as we mentioned, is going to be online in just a few years, is quite powerful.
But I want to touch on the B612 Sentinel Space Telescope. And originally NASA supported their mission, and in fact they signed a Space Act agreement between the two. But that was ripped up, and only days later, I think you'll confirm, NASA announced that they'd be funding their own space telescope. Is that NeoCam? Remarkably similar to Sentinel.
I mean, if you go back to when, you know, the guys at B612 are great. They had a great idea, and they got NASA to agree to do this. And then after a while, the guys at JPL who wanted to do this had their own competing proposal. They said, yeah, we want to do this. Of course, they wanted a lot of money directly from NASA. The B612 guys just wanted technical assistance. They were going to raise their own money. So after a while, the JPL guys, you know, they wanted their, you know, NeoCam. And so by some strange coincidence, NASA went to the fine print on the Space Act agreement and said, well, you know, you haven't done this, you haven't done that yet. And instead of giving these guys a chance, because pretty much they were going to give NASA the spacecraft and operate it for next to nothing in terms of what NASA would have to pay. But internal politics, the JPL, they wanted that responsibility and the money that went with it. So the Space Act agreement got torn up on a technicality, and shazam, a day or two later, suddenly NeoCam gets picked. It was not a coincidence.
You know, asteroids are something that we've known about scientifically for over 200 years now, and I think the earliest ideas that asteroids would represent a resource to humanity and to society is over 100 years ago with Konstantin Tsiolkovsky described it in one of his early writings. We've certainly seen the science advance, we've seen science fiction advance around it, and really it's just been in the last few decades with the survey activities that have dramatically increased our knowledge, with the space missions that have not only flown past but orbited, landed on, and even returned samples from asteroids. It's something now that is very much a science, and really what we see is an inevitability of moving into space and being able to use those resources that are out there to allow us to make that foothold.
We started this company about 6 years ago, with the idea that if you didn't have to bring everything from the surface of Earth into space, you could do a lot more in space.
Yeah.
And the idea of space manufacturing became a reality when we put 3D printers on the International Space Station and started manufacturing the first things ever built off of planet Earth. So we're really interested in creating a new age for space where you don't have to build things that have to survive launch. They don't have to exist in gravity. Maybe they only live in zero gravity, and they're so big they would never fit into a rocket to begin with.
I mean, so that they're some of the most beautiful objects that we can see in the sky, Bob, but potentially the most dangerous to life on Earth as well.
Well, what about other places that may have friendly conditions, that may have water, and which have been pelted by comets, such as Europa, the second Jovian moon outward from Jupiter? Wouldn't it make it more likely than not that there's life there if they have warm, saltwater oceans, plus comet impacts? They've had as many as we have, plus all the amino acids that these comets bring. So bearers of death and bearers of life.
Today, we are going to be looking at different images taken from the Slooh telescopes, welcoming a brand new planet to the neighborhood. And that planet is Proxima B, an Earth-like planet orbiting around Proxima Centauri, the closest star to our own. I know this is way, way speculatory, but if you had to venture a guess, do you think it's more likely that Proxima B is inhabited by life or not? Would you think one way or the other?
Life as we know it here on Earth, we have found in the past few decades that there is some life on Earth that can live and thrive actually under conditions that are very extreme. And even if the planet is more massive and doesn't even, for instance, have an atmosphere, it's still not clear whether life could not exist in the subsurface, protected, for instance, from all these energetic flares that Proxima typically has. So I would say, I would think that if the process that leads to life, so the first steps are quite common and we don't know that yet, then I think, and once life starts on a planet, then it will stay there, and it will probably, I would say that Proxima B would be also inhabited at least by microbial life.
As you said, there's all these flares. And so there's all this radiation hitting the planet. And so one of the things that we thought about is like, what could you actually do? Or do we know life that could survive it? And Michael was already talking about that we know about extreme forms of life that actually could survive in a place like that with a lot of radiation. But the question always will be is like, could it actually start there? And that's the key point that we don't know. But there are some corals here on Earth that if you hit them with a lot of UV light, what they actually do is they start to fluoresce. So they start to glow in visible light. And this is a protection mechanism. That protection mechanism basically breaks down the really harmful, violent radiation that the star puts out in the X-ray and UV, and it breaks it down to non-harmful wavelengths. Would probably, if it starts, be very motivated to actually develop something akin to that, to shelter itself.
We're here to bring you live coverage of the Eta Aquarid meteor shower as Earth plows through the debris trail left by one of the best known comets, Comet Halley. So every meteor we see tonight in the sky, look at these skies above me. I am in, by the way, that little dome just on the far left. You can see there's a light on in the dome. That's where I am at the moment under the stars. So every single meteor we see tonight is a tiny fragment of Comet Halley burning up in our atmosphere. How cool is that? And there is one, there is, bang, our first Eta Aquarid meteor from the guys in the UK. When that comes up on the screen, look for that. That's exactly, what kind of timing is that? This is actually a graphical representation of the radio waves, and you're going to hear it later. We'll actually turn the audio on, and when you see something like that, when you see a bright streak in the middle, that is a meteor.
But why tonight of all nights? Why do meteor showers tend to happen at these very particular times every year? It actually all comes down to our orbit around the sun. Planet Earth circles the sun once every year, so every January it arrives back where it started its journey last year, on the same side of the sun that it was last January. This means that it flies through the same region of space and the same debris this January that it did last January. At certain parts of Earth's orbit, the planet crosses the path of many of these meteoroids over the course of a few days, producing a shower of meteors, like we are expecting tonight. Tonight's shower is known as the Eta Aquarids because the meteors look like they're coming from the constellation of Aquarius. Now,
the Eta Aquarids, which give us only about 40 meteors per hour, is a step downward. Nonetheless, it is number 4 during the year, and this year, right now, the moon is close to new, so it's dark. The conditions are perfect. We can't get any better conditions.
Wow, we got another one from the UK Meteor Observation Network. Those guys are doing well over there. They've got these special low light cameras. You know, they actually use over there this special software which is designed to identify, would you believe, UFOs.
A lot of people don't realize that a meteor is just a name for anything that's whizzing into our atmosphere, coming in from outer space. It could be anything. Piece of an asteroid, piece of a comet, a chunk of a planet even, and that has happened.
Oh, look at this! Yes! We've got another one from the UK Meteor Observation Network. That's a really short one now. Don't forget, Aquariid meteors pretty fast, but sometimes, they leave a trail, as you'll hear from some of our experts. But listen, meteor showers is what we're doing tonight, but it's not everything. Oh, there's another one as well. Oh, that's a corker.
Now, by the time we started keeping records millennia ago, early astronomers had already mapped the stars, named the constellations, even named the planets, and figured out the orbit and phases of the moon. But understanding how things move doesn't mean you entirely understand everything about them. And when there's something you don't understand, it tends to inspire an awful lot of fear and doubt. Halley's Comet, specifically, has been blamed for any number of catastrophes. In Switzerland, it was blamed for earthquakes, red rain, and a number of other strange occurrences, including two-headed animals. In England, some blamed Halley's Comet for the Black Death, the terrible plague that killed anywhere from 75 to 200 million people worldwide during the Middle Ages. And Pope Calixtus III even went so far as to have Halley's Comet excommunicated as an instrument of the devil.
Tonight, we're celebrating the arrival of not just the full moon, but the seasonal blue moon. There you can see, above the horizon, the bright dot. That's not the sun, that is indeed our moon.
Just looking at the moon's limb here, the moon's edge, at the lower left, you can actually see a mountain over the horizon. The moon being only 2,160 miles across, its horizon, its ground slopes and curves a lot faster than ours does. And look at that mountain in the sunlight, catching the rays of the sun.
It's great.
It's actually over the edge. It's sitting on the dark side of the moon, but the mountain is the peak is standing up within view. It's great. There is no object that we see in life other than the sun, which is generally not safe to look at directly. There's nothing that we see that's as round as a perfectly full moon. And
well, the names are never as mysterious as one might think. The full flower moon is an indication of flowers beginning to bloom. That spring flowers forth, if you will.
Well, I love the fact that different tribes across North America had their different names for them, and it's all about storytelling and about putting the world around them, I guess, in their context, in one way or another.
We're thinking back hundreds of years now, right? So it was very much an oral tradition, and there was no calendar per se. There was no certainly television and internet, by which to actually count the days and make appointments. So folks looked to the natural world to be an indication of what time of year it was and what practices that they would pick up and continue at that period.
Actually, while we're just looking at that, let me just move it about for you a little bit so you can see that it's live. There you go. I'm moving the telescope here. Pretty amazing stuff. Wow, look at those mountains. Now, as we move, you see further and further away from the moon being full, more of the features on the edge of the moon start to get shadow on them, and they come alive with this 3D nature.
We can see that the moon is just off the top edge.
and we've got these other two objects nearby. And people who have a clear sky tonight, the northeastern United States is buried under pretty much overcast, but those parts of the world that have clear skies, go on out, look lowish in the southeast, and you'll see what looks like a baseball diamond with the moon at the top of the diamond and several stars forming the other parts of it. And here's what you're seeing. The lowest star, which looks orange, is the famous star in Scorpius, the major star of Scorpius, Antares, supergiant star. The one on first base, that is on the right side of the diamond, that's the planet Mars, and that's the brightest of all the objects, except for the moon, of course. The moon is at the top, would be on second base, and on the left side is the planet Saturn. So if you have a backyard telescope pointed at, if you're going to point it anywhere, I'd say skip the moon, skip Mars, go right to Saturn, and you'll be glad you did.
Tonight is known by some as the sturgeon moon, the full sturgeon moon, you know, that big ugly fish. The full moon at this time of year is really low to the south, isn't it, Bob? But why is that?
Yes, because the full moon does everything opposite to the sun. As the sun sets, the moon rises. The full moon rises.
Full moon.
At the end of the night, when the full moon sets, the sun rises. The full moon is highest when the sun is lowest.
But of course, it's different for people in the southern hemisphere, isn't it? It's the reverse of this. The moon, the full moon, is actually really quite high in the southern hemisphere at this time of year.
Exactly right. Precisely the opposite. And the only time that oppositeness doesn't happen is on the equinoxes. I look forward to next month's equinox show, because then you have evenness, and the opposite of evenness in the astronomical terms is more evenness. So there you have the sun in its average path through the sky, and there you have the moon, the full moon, through its average path through the night sky.
And you told me this evening that the moon can actually make a noise of sorts. What's that about?
The seismometers left behind by the Apollo astronauts showed us that the moon, when it's struck, starts shaking and vibrating, and it doesn't stop after a few seconds. It doesn't stop after a few minutes, the way earthquakes on our planet dampen out after just a few minutes. No, the moon continues to ring like a gong for 2.5 hours.
Wow.
And so that must be telling us that it's very different in its interior than our planet is.
As we've said on our previous full moon shows, many have been named by various peoples down the ages. How on earth did the August full moon become known as the sturgeon moon? Who named it?
Well, like a lot of the moon names, it was conceived by Native Americans. And these were the folks who lived up around the Great Lakes and even Lake Champlain. And they recognized that the fish were in abundance at this time of year. And so they were easy to fish, easy to catch, and so store for later in the season. And these are, in fact, living fossils, these fish. They haven't changed in about 136 million years. They're quite fascinating. They suck food off the floor of the ocean and the lakes and rivers. They don't actually bite. They don't have scales. They have plates. It's a fascinating species.
So this moon, this particular moon, does it have any other names as well? Or did any of the other tribes call it something else? Because
Yes,
you've spoken before that...
It was also called the moon when geese shed their feathers.
Oh, I love that.
Because it was the period in the midsummer when geese were molting and they couldn't fly when they shed their feathers. Now, maybe they were also hunted down, but it was certainly a noticeable pattern, a recurring event every year, you know, in nature. And this was something that the Native Americans noticed. And so they applied this to the moon to give it place in time for them. And also it was the end of fruit moon, because
fruit moon, right.
and a fruit, because the berries and other fruits on trees and bushes were all finished. The harvest was done and the season was over.
Now, we tend to think of moon hoaxes being relatively a modern phenomena, but you've uncovered one from 1835, is that right?
The New York Sun newspaper in 1835 was not selling enough issues, not enough readers, circulation was down, and they wanted to lift it. So on August 25th, 1835, they started a series of articles about what I just described. They claimed that Sir John Herschel, who was out of town at the time, he was in South Africa as it happens, but they claimed that he reported seeing blue unicorns, horned bears, beavers that walked on 2 feet, which is always why I'm suggesting
I
that we
love
look
that
closely. And as well as sheep and zebras and pelicans and cranes and amethyst obelisks and volcanic mountains and forests. Can't you see them? Well, these articles about these discoveries ran for 6 days in the newspaper, and the newspaper was flying off the shelf. People were buying it and talking about it and reading it. And then after a couple of days, they started to think, why is no other newspaper publishing this fantastic story? Well, it became clear that it was a hoax. It was the Great Moon Hoax. People loved it anyway. They didn't mind. And for some time, it was not known who wrote it. All this time, John Herschel, who they said had discovered all these things, was away in South Africa, as I mentioned. And when he came home and learned of it, well, that was the end of the story. He knew nothing up until that time.
What is the first quarter moon that occurred on Friday? Why does the moon even have phases? And why is this particular phase of the moon so interesting to look at?
Look at the moon that we're looking at right now, a couple of days after the first quarter moon. It's a gibbous moon, and if you ask most people, what is that phase called, they don't know. It comes from an Old English word meaning protruding. But a gibbous moon can be anything from slightly fatter than half to virtually full, just a little bit off, out of route. The bottom of the picture, you see tons of craters. Yet within those dark blotches, the mare, there are almost none. And so this is telling you about the history of the moon. Obviously, meteor impacts must have been pretty random in hitting the moon. So if you have a lot on the bottom and you have none in the dark areas, that could not have been a random occurrence. So this tells us that something must have covered up the craters that were once there near the middle or just above the middle of the moon. And those were lava seas spreading and drowning them out. Now, there are a few craters, rare, but there's a few within those lava seas, within those dark blotches, and that tells us those are the youngest features on the entire moon. In other words, without being an expert, without being an astronaut, without having to go there at all, just by using the Slooh telescope tonight and looking at the moon, we can figure out the moon's history, its storyline.
What's interesting is that the moon was also one of the first objects to be really understood by humans as a species. We don't actually know when mankind first figured out why their nightly neighbor changed shape the way that it did, but we do know that by the time Ptolemy, the ancient astronomer, wrote down his observations, humans already understood the moon's orbit and what caused the different phases. We know scientifically that the moon directly affects the pull of ocean tides, but some pagan practitioners take it a step further. They believe that the moon actually has an effect on the metaphysical world as well as the physical. The cyclical nature of the moon from each phase onward in an endless cycle, those changes are also represent to some the circle of life, death, and rebirth. It's an essential principle of many pagan faiths.
Notice there's several pockmarked craters that have landed within the smooth mare here, which shows that these are new craters. One more thing we could do is compare those new craters with the craters at the bottom, which are the ancient almost 4.5 billion-year-old craters to see if there's any difference, because that would tell us if there's any weathering on the moon. Certainly on Earth, if you looked at a feature that was 4 billion years old and compared that to a modern geological feature, there'd be no comparison, namely because there wouldn't even be any features from 4 billion years ago. They would have all been erased by wind and water and erosion. And the fact that the craters that are new, that just as observers we can tell are new because they're on top of the lava, look no different from the craters at the bottom, tell us that nothing changes on the moon. Therefore, there can't be wind and water and erosion and rain. And so look at all we have learned just from this Slooh telescope view. We have just recounted the storyline on the moon just by looking at it.
So, many of you may be wondering what an opposition is. Well, the clue is kind of in the name. When Neptune is at opposition, it's positioned opposite the Sun in our sky. So basically, at sunset, the Sun's behind you, Neptune is rising in the east off the other horizon. So the planet's therefore visible virtually all night long. And as I